Hello and good day. I'm Maria Christine Claire B. Sidurosa, 3rd year B, and in this video I will be discussing Chapter 11, Managing Systems Implementation. Phase Description. Systems implementation is the fourth of 5 phases in the system's development life cycle. It includes application development, documentation, testing, training, data conversion, and system changeover. The deliverable for this phase is a completely functioning information system. So when you finish this chapter, you will be able to explain the importance of software quality assurance and software engineering. Describe the application development process for structured, object-oriented, and agile methods. Draw a structure chart showing top-down design, modular design, cohesion, and coupling. Explain the coding process, explain unit integration and system testing. Differentiate program system, operations, and user documentation. List main steps in system installation and evaluation. Develop training plans for various user groups. Compare in-house and outside training. And describe effective training techniques. Describe data conversion and changeover methods. And last, explain post-implementation evaluation and the final report to management. Introduction. Managing systems implementation involves application development, testing, documentation, training, data conversion, system changeover, and post-implementation evaluation of the results. During system implementations, the system design specification serves as a blueprint for constructing the new system. The initial task is application development, and before a changeover can occur, the system must be tested and documented carefully. User must be trained and existing data must be converted. And a formal evaluation of the results take place as part of the final report management. Software quality assurance. So in today's competitive businesses environment, companies are intensely concerned with the quality of their products and services. A successful organization must improve quality in every area, including its information systems. No matter how carefully a system is designed and implemented, problems can occur. Rigorous testing can detect errors during implementation, but it is much less expensive to correct mistakes earlier in the development process. The main objective of software quality assurance is to avoid problems or to identify them as soon as possible. Because poor quality can result from inaccurate requirements, design problems and coding errors, and faulty documentation and ineffective testing. Software engineering. So because quality is so important, you can use an approach called software engineering to manage and improve the quality of the finished system. Software engineering is a software development process that stresses solid design, accurate documentation, and careful testing. Software Engineering Institute at Carnegie Mellon University. Software Engineering Institute is a leader of software engineering and provides quality standards and suggested procedures for software developers and system analysts. Software Engineering Institute's primary objective is to find better, faster, and less expensive methods of software development. So to achieve that goal, Software Engineering Institute designed a set of software development standards called the Capability Maturity Model or CMM. It is used successfully by thousands of organizations around the globe, which was introduced in 1991, which aims to improve software quality, reduce development time, and cut costs. More recently, Software Engineering Institute established a new model called CMMI, or the Capability Maturity Model Integration. It is a new model that integrates software and systems development into a much larger framework called process improvement. More recently, Software Engineering Institute established a new model called CMMI, or the Capability Maturity Model Integration. It is a new model that integrates software and systems development into a much larger framework called process improvement. It regards software as part of a larger quality improvement process rather than as an end in itself. The CMMI tracks an organization's process using 5 maturity levels, from level 1, which is referred to as unpredictable, poorly controlled, and reactive, to level 5, in which the optimal result is process improvements. International Organization for Standardization, or ISO. It is an international body that establishes a standard for many products and services, including software development. ISO states that standards which provide product quality, compatibility, and safety often are taken for granted and noticed only when they are absent. Because software is so important to a company's success, many firms seek assurance that software systems, either purchased or developed in-house, will meet rigid quality standards. In 1991, ISO established a set of guidelines called ISO 9000-3, which provides a quality assurance framework for developing and maintaining software. And in 2004, it was updated and is now referred to as ISO 90003:2004. ISO requires a specific development plan, which outlines a step-by-step process for transforming user requirements into a finished product. ISO standards can be quite detailed. Overview of application development. Application development. It is a process of constructing the programs and code modules that serve as the building blocks of the information system. Popular development options are structured analysis, object-oriented analysis, and agile methods. The objective of application development is to translate the design into program and code modules that will function properly. Review the system design. Task involves in creating system designs. First, break down complex business operations using functional decomposition diagrams, or FDD. Create data flow diagrams, or DFD. Develop an object-oriented model of the new system. Select a development strategy. Design the user interface. Construct entity relationship diagrams, or ERDs. Consider an overall system architecture. Task produced an overall design and a plan for physical implementation. Traditional methods. Building a new system requires a careful planning. After an overall strategy is established, individual modules must be designed, code tested, and documented. After the modules are developed and tested individually, more testing takes place, along with thorough documentation of the entire system, as shown in the example on the screen. A module consists of related program code organized into small units that are easy to understand and maintain. Agile methods. The objective of agile methods is to create the system through an iterative process of planning, designing, coding, and testing. So this is the example of simplified model of an extreme programming project. Systems development tools. System developers also can use multi-purpose tools to help them translate the system logic into proper functioning program modules. These generic tools include entity relationship diagrams, flowcharts, pseudocode, decision tables, and decision trees. Entity relationship diagrams. It is a useful tool regardless of which methodology you are using, because the various relationships, either one-to-one, one-to-many, and many-to-many, must be understood and implemented in the application development process. Flowcharts. It represents logical rules and interaction graphically using a series of symbols connected by arrows. So using flowcharts, programmers can break large systems into subsystems and modules that are easier to understand and code. Pseudocode. It is a technique for representing program logic. Helps describe a program actions that can be implemented in any programming language. In Figure 11-8 illustrates an example of pseudocode that documents a sale or promotion policy. Decision tables and decision trees. It is used to model business logic for an information system. It can also be used during system development, as they develop code modules that implement the logical rules. So in this example shows an example of a decision tree that documents the sale promotion policy. Project management. Even a modest-sized project might have hundreds or even thousands of modules. It is important to set realistic schedules, meet project deadlines, control costs, and maintain quality. And it should use project management tools and techniques to monitor and control the development effort. Structured application development. It is usually involves a top-down approach, which proceeds from a general design to a detailed structure. It breaks the system down into subsystems and modules in a process called partitioning, or also called modular design. Structure charts. It shows the program modules and the relationships among them. It consists of rectangles that represents the program modules with arrows and other symbols that provides additional information. Symbols represents modules, data couples, control couples, conditions, and loops. Module. It is represented by a rectangle, and the types of module are control module, subordinate, and library module. Control module is a higher level module. Subordinate is a lower level modules, and library is a reusable code that can be invoked from more than one point in the chart. The vertical lines at the edges of the rectangle indicates that a module 1.3 is a library module. Next is data couple. It is represented by an arrow with an empty circle. Shows data that one module passes to another. As you can see in the example, the lookup customer name module exchanges data with the maintain customer data module. Control couple. It is represented by an arrow with a filled circle. It shows a message, also called status flag, which one module sends to another. A module uses a flag to signal a specific condition or action to another module. In the given example, the update customer file modules send an account overdue flag back to the maintain customer data module. Condition. Condition is represented by a line with a diamond on one end. It indicates that a control module determines which subordinate modules will be invoked, depending on the specific condition. In the example given, sort inventory parts is a control module with a condition lines that triggers one of the three subordinate modules. Loop. Loop is represented by a curved arrow. It indicates that one or more modules are repeated. So in this diagram shows a structure chart loop which has two repeating modules, which is the get student grades module and calculate GPA modules. Cohesion and coupling are important tools for evaluating the overall design. Cohesion. Cohesion measures a module's scope and processing characteristics. A module that performs a single function or task has a high degree of cohesion, which is desirable. Because it focuses on a single task, a cohesive module is much easier to code and reuse. So for example, a module named Verify Customer Number is more cohesive than a module named Calculate and Print Statements. If you notice the word "and" in a module name, you know that more than one task is involved. If a module must perform multiple tasks, more complex coding is required and the module will be more difficult to create and maintain. If you need to make a module more cohesive, you can split it into two separate units, each with a single function. Example: the figure displayed are two examples of cohesions. By splitting the module Check Customer Number and Check Customer Credit Limit into two separate modules, the cohesion is greatly improved. Coupling. Coupling describes the degree of interdependence among modules. Coupling describes the degree of interdependence among modules. Closely coupled modules that are independent and is desirable are easier to maintain and modify because the logic in one module does not affect other modules. So if a programmer needs an update a loosely coupled module, he or she can accomplish the task in a single location. Tightly coupled modules. One coupled module is a link to internal logic contained in another module. So these are the examples of tightly coupled and loosely coupled structured charts. The tightly coupled example on the left shows that the subordinate module calculate current changes depends on the status flag sent down from the control module update customer balance. It would be preferable to have a modules loosely coupled and logically independent. In the example on the right, a status flag is not needed because the subordinate module apply discount handles discount processing independently. Any logic errors are confined to a single location in the apply discount module. Module. Module is represented by a rectangle, and the types of module are control module, subordinate module, and a library module, in which control is the higher level module, the subordinate module is lower level module, and the library is a reusable code that can be invoked from more than one point in the chart. The vertical lines at the edges of a rectangle indicates that module 1.3 is a library module. Ay, kanina ay bullshit. Module. It is represented by a rectangle, and the types of module are control module, subordinate, and library module. Control module is a higher level module. Subordinate is a lower level modules, and library is a reusable code that can be invoked from more than one point in the chart. The vertical lines at the edges of the rectangle indicates that a module 1.3 is a library module. Next is data couple. It is represented by an arrow with an empty circle. Shows data that one module passes to another. As you can see in the example, the lookup customer name module exchanges data with the maintain customer data module. Control couple. It is represented by an arrow with a failed circle. It shows a message, also called status flag, which one module sends to another. A module uses a flag to signal a specific condition or action to another module. So in this given example, the update customer file module sends an account overdue flag back to the maintain customer data. In the given example, the update customer file modules send an account overdue flag back to the maintain customer data module. Condition. Condition is represented by a line with a diamond on one end. It indicates that a control module determines which subordinate modules will be invoked, depending on the specific condition. In the example shown, sort inventory. In the example given, sort inventory parts is a control module with a condition lines that triggers one of the three subordinate modules. Loop. Loop is represented by a curved arrow. It indicates that one or more modules are repeated. So in this diagram shows a structure chart loop which has two repeating modules, which is the Get Student Grades module and Calculate GPA modules. Cohesion and coupling are important tools for evaluating the overall design. Cohesion. Cohesion measures a module's scope and processing characteristics. A module that performs a single function or task has a high degree of cohesion, which is desirable because it focuses on a single task. A cohesive module is much easier to code and reuse. So for example, a module named Verify Customer Number is more cohesive than a module named Calculate and Print Statements. If you notice, the word "and" in a module name you know that more than one task is involved. If a module must perform multiple tasks, more complex coding is required and the module will be more difficult to create and maintain. If you need to make a module more cohesive, you can split it into two separate units, each with a single function. So, example. The figure displayed are the two types of Example. The figure displayed are two examples of cohesions. By splitting the module Check Customer Number and Check Customer Credit Limit into two separate modules, the cohesion is greatly improved. Coupling. Coupling describes the degree of interdependence among modules. So if a programmer needs to update a loosely coupled module, coupling describes the degree of interdependence among modules. Loosely coupled modules that are independent and is desirable are easier to maintain and modify because the logic in one module does not affect other modules. So if a programmer needs an update a loosely coupled module, he or she can accomplish the task in a single location. Tightly coupled modules. One coupled module is a link to internal logic contained in another module. So these are the examples of tightly coupled and loosely coupled structured charts. The tightly coupled example on the left shows that the subordinate module calculate current changes depends on the status flag sent down from the control module update customer balance. It would be preferable to have modules loosely coupled and logically independent. In the example on the right, a status flag is not needed because the subordinate module apply discount has handled discount processing independently. It would be preferable to have a modules closely coupled and logically independent. In the example on the right, a status flag is not needed because the subordinate module apply discount handles discount processing independently. Any logic errors are confined to a single location in the apply discount module. Drawing a structure chart. So if you use a structured analysis method, your structure charts will be based on the data flow diagrams you created during data and processing model. Typically, you follow 4 steps when you create a structure chart. First is review the data. Drawing a structured chart. If you use a structured analysis method, your structure charts will be based on the data. Drawing a structure chart. So if you use a structured analysis method, your structure charts will be based on the data flow diagrams you created during data and processing modeling. Drawing a structure chart. So if you use a structured analysis method, your structure charts will be based on the DFDs you created during data and process modeling. So typically, you follow 4 steps when you create a structure chart. First is review the data flow diagrams. First step is to review all data flow diagrams for accuracy and completeness, especially if changes have occurred since the system analysis phase. If object models are so well developed, you should analyze them to identify the objects, the methods that each object must perform, and the relationships among the objects. A method is similar to a functional primitive and requires the code implement the necessary actions. Step 2. Identify modules and relationships. To transform functional primitives or object methods into program modules. When analyzing a set of DFDs, remember that each DFD level represents a processing level. It works from the context diagram to the lower level diagrams, identifying control modules and subordinate modules until you reach a functional primitives. So this diagram shows a structure chart based on the order system on data flow diagrams. The 3 level of structure charts relates to the 3 data flow diagrams levels. Step 3. Add couples, loops, and conditions. So if you also develop an object model, you can review the class diagrams and object relationship diagrams to be sure that you understand the interaction among the objects. It is to identify the elements that pass from one module to another. In addition to adding the data couples, you add control couples where a module is sending a control parameter or flag to another module. Step 4. Analyze the structure chart and the data dictionary. So at this point, the structure chart is ready for careful analysis. So, you need to check each process, data element, or object method to ensure that the chart reflects all previous documentation and the logic is correct. Often, you must draw several versions of the chart. Some case tools can help you analyze the chart and identify the problem areas. And also, determine the modules are strongly cohesive and loosely coupled. Object-oriented application development. It translates an object model directly to an object-oriented programming language. This process is called Object-Oriented Development or OOD. Characteristics of Object-Oriented Application Development. When implementing an object-oriented design, relationships between objects already exist, because object interaction is defined during the object-oriented analysis process. The application structure is represented by the object model itself. Individual object instances belong to classes of objects with similar characteristics. The relationship and interaction among classes described using a class diagram. A class diagram includes the class attributes, which describe the characteristics of objects in the class, and methods, which represents program logic. For example, the customer class describes customer objects. Customer attributes includes number, name, address, and so on. The methods for the customer class includes place order, mostly order, and invoice, and among others. The customer class can exchange messages with the order class. In addition to class diagrams, programmers get an overview of object interaction by using object relationship diagrams that were developed during the object-oriented analysis process. For example, in Figure 11-19, shows an object relationship diagrams for a fitness center. Notice that the model shows the objects and how they interact to perform business functions and transactions. Properly implemented, object-oriented development can speed up projects, reduce costs, and improve overall quality. However, these results are not always achieved. Organizations sometimes have unrealistic expectations and do not spend enough time learning about, preparing for, and implementing object-oriented development process. In summary, to secure the potential benefits of object-oriented development, system analysts must carefully analyze, design, implement, test, and document their object-oriented projects. Implementation of object-oriented designs. The main objective is to translate object methods into program code modules and determine what event message will trigger the execution of each module. To accomplish programmers' analysis, sequence diagrams and state transition diagrams that show the events and message that trigger changes into an object. Object-oriented applications are called event-driven because each event, transaction, or message triggers a corresponding action. Object-oriented cohesion and coupling. The principles of cohesion and coupling also apply to object-oriented application development. Classes should be as loosely coupled or independent of other classes as possible. Methods also should be loosely coupled and highly cohesive. By following the principles, classes and objects are easier to understand and edit. Agile application development. Agile development is a distinctly different systems development method. It shares many of the steps found in traditional development, but uses a high iterative process. The development team is in constant communication with the primary user, who is called the customer, in shaping and forming the system to match the customer's specification. Agile development also focuses on small teams, intense communication, and rapid development iterations. An extreme programming example. Extreme programming is one of the newest agile methods. It is an iterative approach. Suppose that a customer has requested a sales tracking system. So the first step in the XP process would be define the system requirements. A user story is a short, simple requirements definition. Programmers use user stories to determine the project's requirements, priorities, and scopes. Examples of user stories. As the sales manager, I want to identify fast or slow-moving items so I can manage our inventory more effectively. As a store manager, I need enough lead time to replenish my stock so I don't run out of hot items. As a sales representative, I want to offer the best selection of fast-selling items and clear out the old stock that is not moving. And also, programmers can assign a score to each user story that indicates the estimated difficulty of implementation. In addition to user stories, frequent face-to-face meetings with customers provide a higher level of detail as the project progresses. Release plans are to be developed by teams, which specifies when user stories will be implemented and the timing of the release. User stories are implemented in a series of iteration cycles. Iteration cycle includes planning, designing, coding, and testing of one or more features based on user stories. At the beginning of each iteration cycle, which often 2 weeks long, a team holds an iteration planning meeting. Iteration planning meeting it is to break down the user stories into specific tasks that are assigned to team members. Extreme programming uses an interesting concept called parallel programming. It, it uses two programmers to work on the same task on the same computer. One drives or programs while the other navigates or watches. Test-driven. It is designed focuses on end results from the beginning and prevents programmers from straying from their goals. Future of Agile Development. Critics claim it lacks discipline and produces systems of questionable quality. Before implementing Agile development, the proposed system and development methods should be examined carefully. A one-size-fits-all solution does not exist. Coding. Coding is a process of turning program logic into specific instructions that the computer system can execute. Programming environment. Each IT department has its own programming environment and standards. Visual Basic, Python, Ruby, and SQL are examples of commonly used programming languages, and many commercial packages use a proprietary set of commands such as web-centric languages HTML, XML, Java, and Swift. Integrated Development Environment makes it easier to program an interactive software products. Generating code can generate editable program code directly from macros, keystrokes, or mouse actions. In this figure, it shows a very simple example of Visual Basic Code module in Microsoft Access that opens customer order form and produces a beep sound, includes program commands, comments, and error handling procedures. Testing the system. Each program is tested to ensure that it functions correctly. A program is compiled using a language compiler, which helps detect syntax errors or language grammar errors. Desk checking. It is the process of reviewing the program code to spot logic errors, which produce incorrect results. This process can be performed by the person who wrote the program or by other programmers. Organization required a structured walkthrough or code review. Designed walkthrough. It is held to review the interface along with people who will work with the new system and ensure that all necessary features have been included. The next step in application development is to initiate sequence of unit testing, integration testing, and system testing. Unit testing. The testing of an individual program or module. Its objective is to identify and eliminate execution errors that could cause the program to terminate abnormally, and logic errors that could have been missed during test checking. Test data should contain both correct data and erroneous data and should test all possible situations that could occur. Stub testing. A technique to test programs that interact with other programs and files individually before they are integrated into the system. Test plan. It is created during the system's design phase. It contains detail regarding testing procedures. So a comprehensive test plan should include scenarios for every possible situation the program could encounter. Integration testing or link testing. Testing two or more programs that depend on each other to make sure that the programs work together properly. So after completing integration testing, you must perform system testing. System testing involves the entire information system. It includes all typical processing situations and is intended to assure users, developers, and managers that the program meets all the specifications and that all necessary features have been included. System testing major objectives. First is to perform a final test of all programs. Second, verify that the system will handle all input data properly, both valid and invalid. Third, ensure that the IT staff has a documentation and instructions needed to operate the system properly and that backup and restart capabilities of the system are adequate. Fourth, demonstrate that users can interact with the system successfully. Fifth, verify that all system components are integrated properly and that actual processing situations will be handled correctly. Confirm that the information system can handle predicted volumes of data in a timely and efficient manner. And lastly, successful completion of system testing is the key to user and management approval, which is why system tests sometimes are called acceptance tests. Documentation describes an information system and helps the users, managers, and IT staff who must interact with it. It includes program documentation, system documentation, operations documentation, and user documentation. So this is an example of software that can automate the documentation process and help software developers generate accurate, comprehensive reference materials. Documentation is essential for a successful system operation and maintenance. Program documentation. It describes the inputs, outputs, and processing logic for all program modules. Guides programmers who construct modules that are well supported by internal and external comments and descriptions that can be understood and maintained easily. System developers also use defect tracking software, or sometimes called bug tracking software, to document and track program defects, code changes, and replacement code called patches. One popular example is Bugzilla. System documentation. It describes the system's function and how they are implemented. It includes data dictionary entries, data flow diagrams, object models, screen layouts, source documents, and the system request that initiated the project. It is necessary reference material for the programmers and analysts who, who must support and maintain the system. Operations documentation. It contains all the information needed for the processing and distributing online and printed output. It includes the following information. First, program, systems analyst, programmer, and system identification. Second is scheduling information for printed output such as report, run frequency, and deadlines. Third, input files and where they originate and output files and destinations. Fourth, email and report distribution lists. Fifth, physical forms required including online forms. Error and informational messages to operators and restart procedures. Special instructions such as security requirements. Operations documentation should be clear, concise, and available online if possible. User documentation. It consists of instructions and information to users who will interact with the system and includes user manuals, help scripts, and tutorials. Systems analysts usually are responsible for preparing documentation to help users learn the system. It includes the following. First, a system overview that clearly describes all major system features, capabilities, and limitations. Description of source document content, preparation, processing, and samples. Overview of menu and data entry screen options, contents, and processing instructions. Examples of reports that are produced regularly or available at the user's request, including samples. Next, security and audit trail information. Explanation of responsibility for a specific input, output, or processing requirements. Procedures for requesting changes and reporting problems. Examples of exceptions and errors situations. Frequently asked questions. Explanation on how to get help and procedures for updating the user manual. Many users prefer online documentation, which provides immediate help when they have questions or encounter problems. Effective online documentation is an important productivity tool. It is written documentation material is also available. Management approval. After system testing is complete, the results are presented to the management. Test results should be described. Status of all required documentation should be updated. Input from users who participated in system testing should be summarized. Detailed time schedules, cost estimates, and staffing requirements for making the system fully operational should be provided. System installation and evaluation. It describes system installation and evaluation tasks that are performed for every information systems project, whether you develop the application in-house or purchase it as a commercial package. The remaining steps in systems implementation. Prepare a separate operational and test environment, provide training for users, managers, and IT staff, perform a data conversion and system changeover. Carry out a post-implementation evaluation of the system. Present a final report to management. Operational and test environments. Operational environment or production environment, it is the environment for the actual system operation. Test environment, the environment that analysts and programmers use to develop and maintain programs. Figure 11-30 shows the differences between test environment and operational environment. The operational environment includes hardware and software configurations and settings, system utilities and telecommunication resources, and any other components that might affect the system performance. So if you have to build or upgrade network resources to support the new system, you must test the platform rigorously before system installation begins. Training. No system can be successful without proper training, whether it involves software, hardware, or manufacturing. Training plan. It identifies who should receive training and what training is required. An organization should be observed carefully to determine how the system will support business operations and who will be involved and affected. The three main groups of training are users, managers, and IT staff. Vendor training. Required if the system includes the purchase of hardware or software. The scope is limited to a standard version of the vendor's software or hardware. Webinars, podcasts, and tutorials. Webinar. Webinar, which combines the word web and seminar. It is an internet-based training session that provides an interactive experience. Webcast, which is one-way transmission, whenever a user wants or needs training support. Podcast. It refers to a web-based broadcast that allows a user to download multimedia files to a PC or a portable device. The advantage of a podcast is that subscribers can access the recorded material anywhere and anytime. So this is an example of a webinar and a podcast. Tutorials. A series of online and interactive lessons that present material and provide a dialogue with users, and can be developed by software vendors or by a company's IT team. Outside training resources. If you decided to investigate outside training resources, many training consultants, institutes, and firms are always available that provide either a standardized or customized training package. Contact a training provider and obtain references from clients. You can also seek assistance from nonprofit sources with an interest in training, including universities, industry associations, and information management organizations. Training tips. When developing a training program, you should keep the following guidelines in mind. First, train people in groups with separate training programs for distinct groups, which makes the most efficient of time and training facilities. Second, select the most effective place to conduct the training. Training employees at your company's locations offers several advantages. Third, provide for learning by hearing, seeing, and doing. Some people learn best from lectures, discussions, and question and answer sessions. And last, rely on previous trainees. After one group of users has been trained, they can assist others. Train the trainer. Strategy: you can select knowledgeable users who will conduct sessions for others. Interactive training. A relationship exists between training methods and costs. Less expensive methods can be used, including training manuals, printed handouts, and online materials. The most effective training is interactive, self-paced, and multimedia-based. Online training. Training lessons should include step-by-step instructions for using the features of the information system. Training material should include a reference section that summarizes all options and commands, lists all possible error messages, and what actions the user should take when a problem arises. A full-scale test or simulation must be conducted after the training is complete. Video tutorials. You don't have to be a professional video developer to create effective training tutorials. So this shows a step-by-step plan for creating a video tutorial. Data conversion. It is an important part of the system installation process. Existing data is loaded into the new system. Data conversion strategies. It automates the data conversion process if possible. Old systems may be able to export data in ODBC or Open Database Connectivity formats, an industry standard protocol that allows DBMS from various vendors to interact and exchange data. Data conversion security and controls. Maintain strict input controls during the conversion process. Ensure that all system control measures are in place and operational to protect data from unauthorized access and to help prevent incorrect input. Ensure that error-free data is fed into the new system. System changeover. It is the process of putting the new information system online and retiring the old system. Can be rapid or slow, depending on the method. Changeover methods, which are direct cutover, which is similar to throwing a switch that instantly changes over the old system to the new. Parallel operation. It requires the both systems run simultaneously for a specified period, which is slowest method. The two methods, pilot and phased operation, fall somewhere between direct cutover and parallel operation. Direct cutover. It enables changeover when the new system becomes operational. Least expensive changeover method. The IT group has to operate and maintain only one system at a time. Parallel operation. Changeover method requires that both the new and the old information systems operate fully for a specified period. The advantage of parallel operation is a lower level of risk. The old system can be used as backup. Not practical if the old and new systems are incompatible. Pilot operation implements the complete new system at the selected location of the company. Pilot site group that uses the new system first. Reduces the risk of system failure. It is less expensive than parallel operation. Phased operation allows you to implement the new systems in stages or modules. Combines direct cutover and parallel operation to reduce risk and cost. Its advantage of a phased approach is that the risk of errors or failures is limited to the implemented module only. It is less expensive than full parallel operation. It shows that each changeover methods has risk and cost factors. Post-implementation tasks. Once the new system is operational, you must perform the two additional tasks, which is to prepare a post-implementation evaluation and deliver a final report to the management. Post-implementation evaluation. It assesses the overall quality of the information system. It includes feedback of the following areas. First, accuracy, completeness, timelines of information, system output, and user satisfaction. System reliability and maintainability. Adequacy of system controls and security measures. Hardware efficiency and platform performance. Effectiveness of database implementations. Performance of the IT team. Completeness and quality of documentation. Quality and effectiveness of training. Accuracy of cost-benefit estimates and development schedules. So when evaluating a system, interview members of management and key users. Observe users and computer operations personnel actually working with the new information system. Read all documentation and training materials. Examine all source documents, output reports, and screen displays. Use questionnaires to gather information and opinions from a larger number of users. Analyze, maintain, and help desk logs. So it shows the first page of a sample user evaluation form for the new information system, where users evaluate 18 separate elements on a numerical scale so the results can be tabulated easily. Final report to management. The final report to management marks the end of the system's development work. It is submitted at the end of the SDLC phase includes final version of all system documentation, planned modification and enhancement to the system that have been identified. Recap all systems development costs and schedules. Comparison of actual costs and schedules to the original estimates. Post-implementation evaluation if it has been performed. So that would be all, and thank you.